Hello, everyone. Let's continue our discussion on Chapter 6 of data mining algorithms. And here is the last section on the big data data mining algorithms. So as we mentioned earlier, we know that what is big data? It has a couple of major characteristics: volume, velocity, variety, value, and veracity. And because of this nature or characteristics, it actually poses significant extra challenges compared to smaller dataset. What are the key challenging issues for big data, especially for the data mining algorithms? Number one, data samples may not be statistically independent. That's the traditional data mining techniques based on the independent sampling assumption may not work well. That's the first issue. Second issue, the data set can be extremely large, much larger than the physical memory of a computer. Therefore, some kind of resampling has to be done. Number three, data can be dynamical and noisy. Data can also be incomplete with missing data. Then some sort of special techniques to cope with non-stationarity or uncertainty has to be done. And number four, challenging issues for big data is the high dimensionality and high volumes may require high computation costs, which may be a major constraint in many applications in practice. Just keep this in mind, then you would understand the algorithm that we're going to discuss is trying to deal with these challenges. In other words, high dimensionality, a lot of columns, and trying to come back with some sort of resampling-based algorithm that helps to deal with this high dimensionality. So two major algorithms that we are going to discuss. One is called BFR, Bradley-Fayette-Rayner algorithm, and the second one is CURE, clustering using representative algorithm. Let's look at BFR. It is based upon k-means algorithm, k-means clustering algorithm, and then it is applied to high-dimensional data. It assumes that the data are distributed around centroids according to a Gaussian distribution in Euclidean space. So here I want to mention one key observation that you should always pay attention, that is assumption, right? The algorithm, what is the assumption for this algorithm? That helps you to make a decision on whether you should be choosing a specific algorithm or testing on a specific algorithm. In other words, you should think about, oh, does my data follow this satisfies all these assumptions? If it does, maybe I can continue with the experiment of these algorithms. Otherwise, maybe I should start thinking about some other possibilities. So just pay attention to each algorithm's assumptions, and when you are trying to apply these algorithms, you should know whether these assumptions are being satisfied. Okay, here's BFR algorithm. It chooses a small subset of the big data using k-means or hierarchical methods to find the initial key clusters. So you resampling the data and then do a hierarchical clustering or k-means clustering to figure out the first key clusters. And then you take each chunk, a subset from the big data, do the following. You assign the data points and summarize the clusters, and then discuss the data. And then you compress and merge points that are close to each other, forming compressed sets. And you retain the data sets that are not assigned or not close to each other, are forming a retained sets. So here we have some definition. First thing, what you do is calculate the dimension-wise sum. What is dimension-wise sum? Essentially, for a specific variable in this subset, what is the summation of for this dimension xi? In this subset for xi, what is the summation of all the values? And then use summation of I divided by n, which is essentially the mean of this dimension. And then you also calculate something called sum of data squared. Sum squared is the sum of the square of all the data points in the ith dimension. So you use sum squared minus the mean squared, which is a variance in the ith dimension. So you calculate this, and then you try to update. So now things says, okay, how can we assign a new point to the specific cluster? It's actually the same as what we discussed earlier for k-means, right? So you can leverage Mahalanobis distance between this x to the cluster centroid. So you can calculate the centroid and use this xi minus the ci divided by the variance sum squared and squared sum and square root. Use this distance to make a decision whether you want to assign a new point to the specific cluster. So you could update after that. For points that are assigned to a cluster, including any mini cluster, update the centroid and other metrics, then discuss such point that's already assigned. And then finally, after going through all the subsets of the data or loading the last chunk of the data, post-process the retained sets and compressed sets by either assigning each point to the cluster of the nearest centroid or discarding them as outliers. So it has a retain concept and a discarding concept. But the idea is get a subset, get key clusters, make a decision on whether some centroid should be returned or make a decision on some observation should be returned or should be discarded. And the reason, the metrics that you can decide whether they should be assigned to a specific cluster would be based on this distance metric. That's BFR algorithm. Let's look at Cure algorithm. BFR algorithm is efficient. It is mainly for data sets that are symmetric around clusters. So when the data has some weird shape like S-shape or rings type of shape, then you want to think about Cure algorithm. It's very similar. Let's take a look. You can choose a small sample and then use k-means or hierarchical methods to find initial clusters and select a small set of the points from each cluster to be representative points. Just try to pick these points that are far away from each other if possible. And then move each of the representative points a fixed fraction, typically 20% of the distance between its location to the centroid of its cluster. You move them and then merge two clusters if they have a pair of represented points that are sufficiently close. So you already did this sample, and then you did this initial clustering, and then you pick some representative points from each cluster, and then you are trying to move those cluster. After you move those cluster, you check whether the new points that you move is somewhat close. If they are close, you merge them to come back with a new cluster. So initially, if you have k cluster, you merge two of them together, now it becomes k minus 1, could be k minus 2, could be k minus 3. You can leverage this algorithm and repeat these processes and merge until no more clusters are close enough to be merged. And then you carry out the point assignment for all the rest of points in the big data. So that is the Q algorithm. And it can be very efficient in practice, though the problem with Q algorithm is it cannot guarantee global optimality. For large data set, it's impractical to reach true global optimum using Q algorithm. Just bear this in back of your head so that when you really have a chance to leverage Q algorithm, you should know its drawback and potential risks as well. Okay, that's BFR and Q for big data. Just be aware that all of these algorithms for data mining is implemented in all the software packages. For example, in R, it has k-means, KNN, and decision trees and random forest. In addition to that, R can also be paired with big databases such as Amazon Redshift and Google BigQuery. Python has k-means and decision tree classifiers, and also have pandas, numpy, scipy, and machine learning libraries such as MLPy, Tino, sklearn, and others that incorporates some sort of this algorithm that we discussed, all these clustering, Bayesian networks, classification, Bayesian classifiers, etc. And MATLAB has all these functionalities such as k-means, fit CK, nearest neighbor, fit C-tree, and fit ensemble, which is random forest. And RapidMiner has all these classifier implemented, including logistic regression decision trees, naive Bayesian classifier, and random forest. All of these algorithms are implemented in many other languages as well, such as Java and C++. Okay, thank you. And this concludes our discussion on Chapter 6, Data Mining Algorithms.